It is my really great pleasure to introduce Dr. Nachum Soroker from the Loewenstein Rehabilitation Hospital. Nachum did his MD studies here in Hadassah Medical School, and then did his training as a specialist in physical medicine and rehabilitation at the Loewenstein Hospital, where he's still at. In between, he did several fellowships both in the US and in the UK in several aspects of rehabilitation, and he has been since a real authority on neuropsychology, cognitive neuropsychology, and especially about the clinical rehabilitation of patients with brain damage. He's been the head of the association, Aviv, and he was a signatory in several international organizations for rehabilitation. And I'm saying this because he is a prime example of somebody who is very dedicated to the clinics, and he always puts clear constraints on where he can devote his time to science, not before he's finished everything to do with his patients. And at the same time, he's also a prime scientist. It is a special pleasure for me because Nachum is single-handedly the reason that I'm in neuroscience. As a medical student, I bumped into his department, not so willingly, but had to, and it actually changed the course of my career. So I'm really indebted to it, and I'm sure that we're going to hear a very fascinating story today. Thanks, Nachum.
Thank you. Do you hear me? It works. Pay attention to the figures that appear from time to time on the slides. They were all made by What now? Do you hear me now? Is it okay now? Yes? Okay. I was saying that it will be good for the purposes of the lecture that you pay attention to these kind of figures that appear from time to time on the slides. All of them were made by patients in our department, patients with the right parietal cortex damage, with neglect patients, and they actually are among the greatest puzzles that one can see when examining these kind of patients. I don't know if time will allow, but if there will be enough time, I will be trying to cover these 6 points in the lecture. First, to give kind of a survey of neglect symptomatology. What happens when the right posterior parietal cortex is damaged? What happens to conscious awareness? Then I will try to show that whatever happens cannot be attributed to a simple or a primary sensory deficit, neither in visual system nor in other modalities of perception. And this will be done by a process of manipulating the retrieval mode in kind of a Sperling task. You will see that. And then I'll go into some closer look at what happens in a condition termed extinction. Extinction is one of the elements of the symptom complex that we call unilateral spatial neglect. And extinction is the condition where a person with a right-sided damage, for example, is able to perceive consciously a left-sided stimulus. But when this same stimulus in this same location is presented simultaneously with another stimulus on the ipsilateral side, the contralateral stimulus disappears from awareness. But this is a condition of extinction, and I will try to show that this is a good paradigm for thinking about what happens when right hemisphere and left hemisphere are dealing with a perceptual task simultaneously. Okay, so this is a specific condition that is sometimes thought to be independent of the entire neglect syndrome. Then, fourth part, I will try to show what happens when stroke affects both the right and the left posterior parietal cortex. This will be exemplified by what happens in the syndrome called Balint syndrome. Balint syndrome is a condition not often seen where a patient has a complex of symptoms. Among them, the major is called simultanagnosia, which means that the person is unable to understand the visual scene, although he's able to perceive correctly, identify correctly different elements within the scene. Okay, I will try to show that this has something to do, or if we examine this kind of patient, we can learn something about what happens when one hemisphere or one PPC is affected. Then, in part 5, I will try to show you what happens when the two posterior parietal cortices are intact but disconnected. Okay, this will be shown by a patient that we had who had to go through a forebrain commissurotomy, complete commissurotomy, callosal section, because of intractable epilepsy. And you will see something very interesting in the performance of this patient. Okay, and this will probably bring some doubt on the relationship between neglect phenomena, the typical neglect phenomena, and the hemisphere that produces them. You will see that actually the intact left hemisphere, when operating with the right hand, disconnected from the right hemisphere, and the left hemisphere, disconnected from the right hemisphere, is actually producing the phenomenology that we usually see in patients with right parietal cortex damage and neglect. Finally, all this culminates into some view of the interrelationship between right and left posterior parietal cortices. And now this relationship is manifested in all these clinical settings. And there will be some implication coming from this view that I will try to develop for neuromodulatory efforts that are now done. By this I mean interventions that aim to increase the adaptability of plasticity in the brain, in the damaged brain. Usually, in cases of neglect, we think that, for example, stimulating the right hemisphere or inhibiting the left hemisphere is the proper thing to do. But after we shall see all this, there might be a doubt on the intelligence of this approach. Okay, so we shall start with neglect syndrome. We are talking about left space unawareness that follows usually a right posterior parietal cortex damage. I'm not going into the specificities of the exact location. There is a big debate on what exactly is more important, whether it is the superior temporal gyrus or the temporoparietal junction or the posterior parietal cortex and what part of the posterior parietal cortex. And there are different theories and different ways of gathering evidence on that. But anyway, we shall talk, because most of the patients with neglect have involvement of the posterior parietal cortex. It will be annotated here as RPPC or LPPC, posterior parietal cortex. I'm talking about that. So unilateral spatial neglect, here written as USN, is a common sequel of stroke, mainly in the right posterior parietal cortex or superior temporal gyrus area, but you can see neglect for the right side following left hemisphere damage. This is not very infrequent, only that a persistent severe neglect usually follows the right hemisphere damage, and usually in these areas. And what happens? What happens is that left-sided stimuli, either in the subject or the object coordinates, receive inadequate search and less or no attention. and hence they remain outside awareness. When I'm speaking about different coordinate frames, you should understand that, for example, if I had neglect from a right PPC damage, probably I wouldn't notice that Elior is sitting here in the second row because she's on my left. This would be egocentric space, okay? The left of the egocentric space. The egocentric space is divided in two mainly by the mid-sagittal plane, okay? But patient with neglect may neglect the left, for example, the left side of a single letter in a word that might be on the right side of the page. For example, in Hebrew, Reish and Nun, or no, Reish and Taf. Reish and Taf. Reish and Taf have the right side of the letter the same, but the left side different. So patient with neglect may have an error distinguishing between these two letters, irrespective of where these letters appear on a word, and where the word appears in the page. Of course, it might be more severe if also the egocentric space is involved and the word and the letter appear more on the left, but it may occur also on the right. So this is type of spatial disturbance that occurs on the left of allocentric space, of object-based coordinate.
I have a question about the pictures in the previous slide. So it looks like there's different degrees of neglect. In one case, you're holding one leg, in the other case, they're drawing two legs. So these are different patients drawing these pictures?
Yes, each one is a different patient. Usually one person produces the human figure in the same way from around, I think, high school on. There is a quite stable representation, and it will be quite the same if you do it with the right hand or the left hand, or even with the mouse. So these are all. Each one of them is made by a different subject. I wouldn't say that if it is more formed, I don't know, maybe here than here, it means that there is more neglect. Actually, there are many tests for neglect, and all of them double dissociate. So there is no golden standard for neglect and no golden standard for the severity of neglect. The severity might be in one patient in this specific task, which is representational drawing, might be manifested more in this than in this, and in another task, for example, a cancellation task or a bisection task, it might be different. Maybe if only urgent question, because otherwise I will not reach even the third part of my. What? Do we know why the syndrome is asymmetric? Oh. First of all, it is asymmetric only in humans. In experimental neglect of animals, it is more or less symmetric. So if you have damage, experimental damage in the right posterior parietal cortex, and you have a video of the animal from top of the cage, you will see that this animal is going to do the circling mainly to the right. And if he has the damage in the left, the homolog area in the left posterior occipitoparietal cortex, he will do it in the other direction. So it is in the human that it is asymmetric. And there are many theories why it happens that it's asymmetric, mainly because, or possibly because, in the left hemisphere, much of this area is occupied by language processing. But so the question is, why is the left missing? Which is like asking why neglect happens. And I don't know the answer. Although I know many explanations, verbal explanation. But when you look at this kind of thing, you actually don't know exactly why it happens. And I'll just give you one clinical point of information. A patient with neglect stays in a hospital 40 days more than a patient without neglect, by the mean. Each day costs around 1,000 shekel. So this is the cost of neglect, which means that if I knew the answer, you could understand that probably I could manipulate, by knowing the answer, I could manipulate the situation in some adequate way and improve the situation of the patient. But it's still a very big problem, neglect today. And the large amount of research done on neglect is not motivated only by the interest that it arises from this symptom complex, but also from the clinical importance. Actually, the existence of neglect is the most important factor for the prediction of the rehabilitation outcome of right hemisphere damaged stroke patients, more than anything else. In the left, it is the existence or non-existence of aphasia. In the right, existence or non-existence of neglect. So this is a very important issue. You can understand, actually, that if a patient is unable to attend to what happens in his left and is paralyzed on the left, and all the rehab effort is to teach him to do something with the left, it will take much more time, much more labor to do that. So you can think of it as some kind of lack of a sensory feedback. He produces something, but as he is unable to monitor what happens in the left, he leaves it like this. Or that he has an inappropriate representation of these kind of figures. This is hard to believe, yes, that one think of a clock face with the numbers only from 12 to 6. So probably the first explanation is more adequate. But anyway, why salient left-sided stimuli fail to induce conscious perception? See, for example, the performance of this patient. This is a patient with a pure PPC damage, posterior parietal cortex damage. He has no sensory loss, no visual field defect, no motor paralysis, only neglect. And this is what the way he performs a cancellation task 14 days after the onset of his stroke. You can see that the task here is to signalize or to circle all the small stars. Yes, the small stars are the target stimuli. And you can see that he's doing this time after another on the right, and sometimes he put the circle on the distractors, but he doesn't go to the left. Why he doesn't go to the left? This is done with an A4 paper on the table in front of him, and he's free to do it until he says that he finished, that he covered all the circles, all the stars, you see? And he can move his head as he wishes, and he can move his eyes as he wishes, but he doesn't tend to do that. Why? He doesn't tend to explore the left side of the space. Okay, this is the same patient. This is an admission to the Loewenstein hospital, and this is the discharge 55 days after the onset. You can see that he improved.
Are you aware that they're unaware?
Can you be aware of unawareness?
If you're told.
Can you be aware of unawareness?
If you're told.
Sure.
If you're told.
I was not aware a minute ago of something.
So you are aware of the unawareness?
Well, like if you ask them after, I think that's what you'll have in mind. If you ask them after.
But this is not awareness for unawareness. This would be awareness of that nothing happened.
Okay, so let's just.
You to be aware of unawareness, you need to know that it happened. But if you know that it happened, you are aware of it. So.
If you point out the missed stars, and they say, "Oh, I missed this one," or
okay, this can happen. You should also know that in patient, this goes to the issue of anosognosia. Anosognosia is a situation when the patient with a brain damage doesn't know that he is ill. For example, he doesn't know that he's paralyzed or that he has a sensory loss or a visual field defect. And they dissociate these different kinds of anosognosia. For example, a phasic patient with Wernicke aphasia, often they talk to you for half an hour and they say nothing and they don't understand what you say, but you are aware of the fact that there is no communication, but they are not aware. So it's very tricky what awareness actually means here. I don't think they can be fully aware of that. Sometimes what happened, let me tell you, sometimes I had a patient who was the dean of the Faculty of Medicine in Tel Aviv University. This doesn't explain, Yossi. But anyway, and he had a very severe neglect. And you know, one of the things that you do when you have this kind of a problem that you don't allocate attention to left-sided stimuli, you tell the patient, well, you have a problem on the left, you miss things on the left, you may fall. Pay attention to the left. This would be moving attention by a top-down allocation to compensate for a bottom-up failure. Okay, this is a verbal instruction this patient can understand. And they can repeat the instruction. You call it awareness. Their behavior will show you that they remain unaware. They might produce verbal description of the neglect syndrome. Okay? But the awareness as shown by the behavior of the patient might remain very, very much reduced. Now, it is unlikely that we are talking about a problem, a simple sensory deficit. All those who returned last summer from Milano get good memories from this place. This is the Piazza del Duomo in Milano. But why I'm showing you this? I'm showing you this because this is one of the good examples, probably the most sexy example of why neglect cannot be explained in terms of a simple sensory deficit. Because here there is nothing of sensory perception here. The patients that first were asked to retrieve from memory the shops here around the Piazza del Duomo in Milan, in front of the Cathedral of Milan, they were in the hospital at the time of this mental exercise. They were actually given this task by Eduardo Biziak, one of very famous and ingenious person in the research of neglect, and he asked this patient, who of course knew this location very well, he asked them to imagine themselves being in the Cathedral Square, first time with their back next to the door, like this, okay, like this. And then from this imaginary place, yes, they had to retrieve the shops, the names of the shops here in the northern wing and in the southern wing, around the square, okay? So they managed to report or to retrieve from long-term memory only those shops that are in the northern wing, but not in the southern wing. So the northern is from this imaginary place, this is on the right, yes, and the south is on the left. And after they finished that, he asked them to imagine themselves, but now from here, just like you are now, facing the cathedral, okay, which means that the direction is now opposite than before. And then again, the same task, but now they were able to report, retrieve from memory the shops in the southern place, in the southern part, but not in the north. This is called the Piazza effect, and it was reproduced in other places. It's not peculiar to the people with neglect that live in Milano. Okay. So this shows actually that the problem is much deeper than a simple peripheral sensory disturbance. It has to do with something with the representation of space, probably, the representation of space, okay? Also, it's often multi-modal. So the patient with neglect in the visual modality might show neglect in the auditory modality, the somatosensory modality. So this brings two lines of theorizing in the neglect area. One stresses the importance of attention, spatial attention, and the other of representation of space. These two lines of explanatory lines are not mutually exclusive, actually. So with this, we finish with some very short overview of the symptomatology of neglect, and we can go to another evidence that we are not dealing with a simple sensory problem. And this is a study that we have done some years ago, and then we augmented it and changed it. And anyway, I will tell you just the essential of it. Okay. We asked ourselves, as most patients with neglect have a middle cerebral artery infarctions, and this kind of damage does not affect the visual pathways, nor the primary visual cortex, why don't they see salient objects on the left? Okay? This was the question. Well, in the passage of the information, in the different stages of visual processing, the information is blocked, so it does not get access into conscious awareness. This was the question that we wanted to ask, and we devised an experiment that enables to see what happens in a stage, a hypothetical stage of processing that is called the iconic store, or the iconic buffer. It is a place where visual information is maintained for some hundreds of milliseconds, probably 500 milliseconds, and we wanted to see what happens there. Now here you can see normalized lesion data from patients with neglect. All of these are patients with neglect. And you can see, if you look at this row, I don't know if you can see it clearly here, this row and this one, if you look at the posterior medial side, you will see here the primary visual cortex, and you will see that it is not affected in the most of the patients. It is intact, actually. So they have a primary visual cortex on the right, which is intact, but they don't see on the left, okay? And the question is why? So here is the experiment. We manipulated the retrieval mode during data maintenance in the iconic store, and our aim was to see whether this kind of manipulation can bring information which is destined to be neglected, which normally this kind of patient don't see, whether by this manipulation of retrieval mode we can bring this information into conscious awareness. So we utilized George Sperling's method of partial report. You probably recall this is a classic experiment. For example, if you show normal subject this kind of array of letters, and for a short period of time, they will be able to retrieve afterwards, immediately afterwards, maybe 3, 4, or 5 of the letters, not more than this. This can be, for example, ARDY, or I don't know, ARHD, depending on how this patient screened the information. I don't know how. Well, but anyway, this is the limit. So what George Sperling did is to produce a post-exposure cue in the form of a high or a low tone. When it was a high tone, this meant for the subject that he is required to retrieve only the upper row. If it was a low tone, this was the sign that he has to retrieve only the lower row. So, although the cue was given after the disappearance of this matrix of the of letters, the subjects managed by this partial report mode of retrieval to reproduce again 4. If it was a high tone, it was the 4 in the upper row. It was the low tone, it was the 4 in the lower row. So partial report, unlike whole report, shows you that the acquisition of the information was complete. Okay? So at the time that the cue was given, here, in this passage of time, at the time the cue was given, all the information was there in the system. Okay? We wanted to see if this can help neglect patients retrieve information from the left. Okay? If they capture this information, okay, and if they can bring this information into this hypothetical store, which is called the icon, okay, or very short-term memory. So this was the idea. Now, the effectiveness of the cue in the George Sperling experiment is maintained for no more than 500 milliseconds. So this is the time, the duration of the time that the information is thought to be maintained in this store. Okay? Of course, the most effective is to produce the cue immediately after the disappearance of the stimulus. Okay? But you can give it a bit later, but no more than 500 milliseconds. After 500 milliseconds, there is no advantage for this. You go back to the same condition as the whole report. Okay? So this is what we did with the neglect patients. All the patients had all the signs of neglect. For example, this kind of performance, or you see a typical line bisection deviation to the right. Okay? And in a reaction time paradigm that Leon Doel here is responsible for, it's called the Starry Night. It's called the Starry Night because you love Don McLean, or I don't know. Anyway, it's called the Starry Night because what the patient sees in the screen is kind of a starry night. It looks like a starry night. The stars are the distractors, and one of them is different in color. And this is the target stimulus, okay? And when it appears, the task is to immediately press a button. So you can measure the reaction time against the location in the space of the computer screen, okay? And you can see that all the patients had a delayed response on the left, okay? So in both traditional paper and pencil tasks that are used to diagnose neglect, and also in this reaction time paradigm, all the patients had neglect. And here is what we did.
Wait, in this delay thing, did they get it right?
What?
What you showed in the previous slide is that they had a delay on the left.
Yeah, that's true.
But did they get but that means that they actually responded.
They responded, yes.
Okay, so they did respond, so why, if the same patient got those stars, why didn't, and this was not a time test?
No. There are two measures that are derived. One is reaction time, the other one is hit rate. The hit rate is low on the left, and the reaction time for those that...
For hits. So the reaction time is
Yeah.
for hits.
For hits, of course.
Okay, sure. And
Of course.
what's the hit rate?
And the hit rate depends on the severity of neglect. It's usually significantly lower on the left than on the right. And those that are visualized get much prolonged reaction time.
So why is reaction time relevant at all?
It is because...
It's the hit rate that's the main result, isn't it?
Yeah, but for the phenomenon of neglect, of unawareness, it might be. But you see, this unawareness is actually the top of the iceberg of the symptom complex. Even those items that are perceived are not processed normally. There are errors in the processing, and the processing is delayed. So it's good to see it in this way, hit rate and reaction time. So we did it in two forms, this kind of experiment. First, there is fixation, then there is the cue, and then this would be a pre-cue, actually, because it comes before the stimulus. And then there are the stimulus pair, And if the cue went to the left, the partial report in this case would be 2. Okay? Now, for the Sperling mode, there is fixation. Then the target stimuli are presented, and then comes the cue. Of course, it may be to the right, to the left, and in random order. Okay? So the patient doesn't know when the stimuli disappear from vision. He doesn't know where he's going to get the arrow pointing to the left or to the right. Okay? And this is what happened. First, with just a pair of stimuli, one on the left, one on the right. You can see this is an extinction experiment, actually. And you can see this is whole report. Whole report means that you are presented with the two and then asked to say what there was there. So in the right, this is the correct response, and on the left, this is the correct response. You can see the huge difference in the level of correct responding. Then this is the pre-cue, the condition of the pre-cue, the cue that signalizes the spatial location for the partial report that appears before the stimulus. Okay, you can see a bit for the left. It is a bit better, but not significant. And then this is the post-exposure cueing. The post-exposure cueing is much better than the pre-cue and much better than the whole report. Okay, this was the first results that we got in this experiment. So we asked ourselves, what will happen if we enlarge the matrix? If we give 2 stimuli on the right and 2 stimuli on the left? Nobody would believe that a patient in this condition can retrieve 2 stimuli from the left, because this is a very strong extinction condition, actually. But see what happened. On the right, okay, you see that the different... okay, and we also manipulated the stimulus onset asynchrony. That is the time interval between the appearance of the stimulus and the appearance of the cue. Okay, so here you have, see just this. This is the left-sided stimulus. This is the whole report, and you can see that in the whole report, whether the matrix is of 2 or 4 or 6 or even 8, there is very low rate of correct responding for left-sided stimuli in the whole report condition. Actually, something like 10% is correctly reported. But then, these are the pre-cue conditioning. This is 500 milliseconds before the appearance of the stimulus, 100 milliseconds concomitant with the stimulus, and then 100 milliseconds after the appearance of the stimulus pair, okay, or matrix, actually, stimulus. And you can see that here there is a significant improvement, actually. This is an improvement that is achieved within the time that of maintenance of information in the iconic store, okay? So this actually proves that during this time interval, a short time interval, when the information is in the iconic store, actually it is there. See here, in 100 milliseconds of stimulus onset asynchrony, actually there is no difference between left and right. The retrieval rate is, correct retrieval rate is the same, okay? So this actually is a very good proof, I think, that information is captured by the system, it is processed, it is maintained in a correct form within the icon, within a very short-term memory store, this buffer, and it can be manipulated there so that it can reach conscious awareness by this method of the partial report. Okay, so you cannot blame just a top-down mechanism that inhibits the information, say, in the lateral geniculate nucleus or in the retina or somewhere by a top-down mechanism. Until the information reaches at least this hypothetical buffer, the iconic store, it is there in its entirety, and it is available for later conscious perception if you manipulate the retrieval mode in this way. Okay, I think that I said all these conclusions right now. The question that remains, of course, is why and how the information is afterwards blocked. Okay, so this waits for another kind of experiment to show this. Now a word on extinction. Extinction is a condition that has a somewhat different anatomy than other aspects of neglect, because in extinction, actually, you present two stimuli simultaneously to the patient. So there might be a competition between the right and the left hemisphere in this condition, which is not the case necessarily in the other aspect of neglect. Other aspects of neglect are hallmarked by this non-tendency to reach or to explore the left side, as we have seen in the cancellation task, okay? Which is something differently, which is something that has to do with the serial processing, but here we are talking about concomitant processing done by the right hemisphere and the left hemisphere. And let us see what happens here, okay? There might be that there is, in this condition, imbalance between contralaterally oriented right and left hemispheric processors, maintaining reciprocal inhibition. This actually is a very popular view of the neglect, which was first introduced by Marcel Ginsburg in the 70s, which says actually that, and this is a common fact that in neuroscience, that different parts of the neural axis maintain a condition of reciprocal inhibition one with each other. It is known to occur in the tactile commissures, and the idea here is that it is maintained also through the forebrain commissures, okay? So that the right hemisphere inhibits the left inhibits the right, and then when you have a right-sided damage, the left side is disinhibited. This actually is the theory of Marcel Ginsburg. And this theory influenced very much all neuromodulation efforts that are done today, either by TMS or by TDCS or other measures, where we try to manipulate brain plasticity so that this kind of problems will diminish in severity, okay? But there might be that extinction reveals something else, which is some kind of lack of cooperation between the hemispheres, which is a different idea. So that when the two hemispheres have to process a right-sided stimulus and a left-sided stimulus simultaneously, the two posterior parietal cortices are engaged simultaneously, and something we can learn from this specific condition, which, as I said, is different from other aspects of the neglect syndrome. We can learn about the interaction, the ongoing interaction between these two areas. So, just to show you something that we have seen, and it appeared, by the way, this is a study that we have done 5 years ago, but it appeared 2 weeks ago. There is a special issue of Neuropsychologia dedicated entirely to neglect syndrome. I don't know if you've seen it. It's edited by Hans Otto Karnat and Schenk. And one of the studies, actually, and I mentioned this because one of the co-authors there is the late John Driver, who took his life some months ago, and was one of the most important, I think, basic neuroscientists in this field of attention and neglect. And in their study, they utilized this diagram and commented on it, so I took it from there. But what we've seen here is that the location of a stimulus in a given sector of the space, let's say the left-sided space, is not the only determinant of the fate of processing of this stimulus. What I want to say is that what happens on the right concomitantly is very important for the perceptibility of the left-sided stimulus. See what we've done. We first measure independently the contrast threshold, the threshold for perception of contrast, okay, on the left and on the right. Of course, on the left it was higher than on the right, okay. And then we manipulated the balance between the contrast of the right and the left relative to the threshold on each side, okay. And you can see here is what you see is, we called it the extinction effect, which is the difference between perception in condition of bilateral simultaneous stimulation versus perception of a stimulus of the same stimulus when presented in isolation in the same place. Okay, this is the difference between extinction and neglect. Okay, and you can see that if you manipulate the contrast of the left and right, you actually, by increasing the contrast on the right, you see in the right it is 2.5 times the time of the threshold on the right, and on the left it is at threshold level. This is the magnitude of extinction in this condition. Whereas if you give on the left 2.5 times the threshold on the left and the threshold on the right, the extinction level is much less. So actually, and this is important for representational theories of neglect, what happens on the left, the fate of processing of the left-sided stimulus, and the amount of visibility that one can expect for the left-sided stimulus depends actually on what happens in the right, which means on what is going on in the left hemisphere, which processes the right-sided stimulus at the same time. Okay? So the condition of extinction can teach us about interactive mode between the right and the left posterior parietal cortices. We reached the fourth part of the lecture, and we have 10 minutes. Let us see what will happen. What will happen actually when you have not a right-sided posterior parietal cortex damage, but a right and left posterior parietal cortex damage? Is this? I remember your review. You said it is a fake.
That's what I said.
You said it is a fake, if I remember well.
I said that if anything, it's balancing.
Okay. I think it's the imagination of Oliver Sacks, but...
Right, but I said if anything, it was...
Anyway, this is a rare condition. You see here an MRI of a patient that we treated 1 year ago. As you can see, the patient had a bilateral temporo-occipital and parieto-occipital damage, which is the typical anatomy of a symptom complex that we call Balint syndrome. It was first reported by Reza Balint less than 100 years ago, but I think it was 1905 or 8, no? Anyway, 9? Anyway, this is the Balint syndrome. What there is in the Balint syndrome? The Balint syndrome, there is a condition that is called ocular apraxia. Ocular apraxia means that, can you call me Ilan? Nachum. Yes. Again? Okay. Yes. Okay. I cannot move my eyes to this direction. Okay. Can you take this from my hand? You see, Ilan Goldberg doesn't have optic ataxia, but the patient with this kind of damage would do this kind of reaching. This is an optic ataxia. So he cannot actually spatially organize the trajectory of the hand towards the visual object. Okay, this is called optic ataxia, which is more or less what happens with the ocular system, the oculomotor system, which this is the reason why they cannot foveate correctly. But the most important is simultanagnosia. Simultanagnosia means that they cannot understand the visual scene. Not because they are agnostic, which means that they cannot perceive or identify visual object. They can identify visual object, but they cannot identify the scene, the meaning of the scene that is formed from the collection of all the objects. For example, if I'm looking like here, I see a class because there are many people here sitting on chairs, and some of them are still aroused. Not very many, but still. So I understand this scene as a class, okay? But this patient cannot do this. They cannot do this kind of operation, so they might be able to identify, for example, the carrot here, the chair here, and the face here, but not the entire scene. This is called simultanagnosia. And one of the elements that is very, very salient in this symptom complex is the fact that if a patient is able to identify something in the visual field, it fades immediately, or after a very short period of time. We could actually quantify this. Yoram Bonet from the Weizmann Institute worked hours with this patient, and for example, he showed him this picture. I believe you know the man, and he recorded the disappearance or the fading of the left, or actually it is the right and the left eye in the figure. The patient all the time complained that the figure is fading and reappearing, like this, okay? And 60% of the time of the record, there was disappearance of this eye, okay? From the viewer perspective, it is on the left, yes? And much less in this eye, okay? So the fading was a very, very salient feature of this patient. And the idea here, I'm not going to go into the details of this, is that the problem is the problem of actually, again, of some short-term memory stores or buffers that first have to hold a coarse view of the scene based on the analysis of low spatial frequencies, and this is done mainly by the right hemisphere, and this is needed so that focal attention, mediated mainly by the left hemisphere, can move to all the points of interest within the field. Otherwise, what happens is that focal attention goes at one time here and at one time there, so there might be an occasional capturing of an object from this part, and then from this part, and then from this part. This is actually what happens in these patients. In the neglect patient, what might happen is exactly the same, only that because the damage is unilateral, the focal attention of the left hemisphere is by default allocated to the right. Okay? So what the patient sees is that which occurs on the right. Here it wanders. It may be capturing here and then capturing there and capturing there. This is when there is bilateral PPC damage. But when there is only right-sided damage with the right hemisphere, and there is no this matrix based on the low spatial frequency analysis, focal attention, which is needed for the identification of the single objects within the scene, goes to the right. And that is why the patient actually retrieves and is conscious only of the object that occur on the right. Okay, so this is actually a cooperative model. It is not the reciprocal inhibition that I described earlier by the Kinsburg model. It is a cooperative model where the right and the left have to cooperate actually in order to enable conscious perception of the entire field. Now,
is it attention or eye movement?
What?
So you can move your attention, but you can also move your eyes.
Usually when you move your attention, you move your eyes. But you can manipulate movement of attention without moving the eye. This is implicit. Not implicit, actually, covered. orienting. For example, I can now attend to your side without looking at you.
So
It's possible to dissociate the two.
When for example, you could consider auditory scene, what will happen in auditory scene.
Oh, I have very good stories about the auditory scene, actually, but we don't have time. If you want, I'll tell you afterwards. See what happens here. You probably already have noticed that this patient has a very peculiar MRI. You see here, the anterior commissure is sectioned. Here is the lower part of the genu. The genu is the anterior part of the corpus callosum. It is sectioned here. Here is the upper part of the genu, and here is the entire trunk of the corpus callosum, including the splenium. So this is a very massive separation of the right hemisphere and the left hemisphere. And you can see that there is no damage in the posterior parietal cortex in each side. What actually will be the conscious perception of this kind of person? You can examine the conscious perception of the left hemisphere by having it report with the right hand. Okay, whatever occurs in the right hand comes from processing that happens in the left hemisphere. You can try to see what happens in the right hemisphere by having this patient produce something with the left hand. Okay, this of course is very difficult in this kind because the right hemisphere is unable to understand instructions, verbal instructions. Moreover, just to give you some kind of an insight into the condition of this patient, if you put to such a patient something on the left hand with blindfolding, no way he can name the object. No way he can produce a verbal description of the object. Okay? The same object on the right hand, easily detected, easily identified, easily named. Okay? Now, what happens to visual perception in this condition? Have you seen before this kind of pictures? I'm trying to show you this kind of pictures actually from the beginning of the lecture. This is the production of human figure after callosal section by the right hand. This is the production of a flower by the right hand. And this is the production of a clock by the right hand. This is the processing that is done in the isolated left hemisphere. And it is exactly what happens in the neglect syndrome. So usually, you know, in the lesion effect paradigm, when you have a malfunctioning of a given functional system of the brain, and you see that the same patient has a lesion in one part or another, you attribute the function to the lesioned area. So we believe usually that what we see in neglect patients, these atypical or these distorted human figures or clock faces or butterflies or whatever, is the direct result of the damage to the right hemisphere. But here you have the opportunity to test the intact left hemisphere, and the intact left hemisphere actually produces neglect figures, exactly the same figure as neglect. Now let me show you what happens in line bisection. In line bisection, patient with right posterior parietal cortex damage err to the right, which means that their subjective midpoint of the line is on the right. They used to do it with the right hand usually, because the left hand is paralyzed. Okay, they do it with the right hand, and they err to the right. The subjective midpoint is on the right of the true midpoint. Okay, see, this is what the patient with callosal section is doing with the right hand. This is a typical, okay, you see, this is 180 millimeter line to 180 millimeter line. You can see the amount of error here. You probably you're not accustomed to this kind of errors, but I can tell you this is very severe neglect pattern. Very severe neglect pattern. If a patient makes an error of 18 millimeters bisecting a line of 180 millimeters is very severe neglect. So actually, what we see in patients with right posterior parietal cortex damage is exactly the same as what we see after commissurotomy, forebrain commissurotomy, when we give the left hemisphere to produce the similar task, which means actually that the problem might not be that of a rivalry or that of opposing directions or inhibition, etc., from one side to another, but lack of cooperation. Because here is of course, this is the condition that there is no cooperation actually between the two hemispheres because of the callosal section. The left hand here errs to the opposite direction. The left hand is the right hemisphere. It is the right hemisphere. And the error goes to the left of the true midpoint. Okay? So actually what we see when the left hand is doing the bisection is right hemineglect. Right hemineglect.
So
this is the pattern of right hemineglect, and this is the pattern of left hemineglect.
And is it the same extent?
No, it is not of the same extent. This is Warsaw. This is Warsaw. Yes. Yeah. So this is the idea that I wanted to. This is the idea that I wanted to actually to develop here, and I will not go into the sixth part because time is finished. But I just say one word. Today there is much effort in rehabilitation medicine, in neurorehabilitation, to find modes to manipulate brain plasticity. Brain plasticity, this capacity of the damaged brain for reorganization, not only damaged brain, for reorganization, is very important actually. If we learn and we know how to manipulate the brain plasticity so that the changes that occur with this reorganization go in favor of patient functioning rather than impairing function further, which is the case in many occasions of plasticity, this will be very important. So all this area, this new area, I would say, is called neuromodulation. And it is exerted mainly by applying magnetic stimulation on the right or on the left. Okay, this can be facilitatory stimulation or inhibitory stimulation. Or you can do it with electrical stimulation, direct transcranial stimulation, TDCS. You can use the anodal pole to stimulate, to facilitate, to excite the cortex behind, and you can use the cathodal for the opposite effect. Okay, and in the neglect area, and also in aphasia, and also in motor problems, the tendency is to follow the idea of reciprocal inhibition, which means that in the case of neglect, you are going to inhibit the left hemisphere and excite the right hemisphere. But if what is important is actually cooperation rather than competition, as is shown, I think, in many occasions of what I've shown you here, probably you need to think in a deeper or more delicate way on how to do this neuromodulatory effect. Okay? I wanted to show you some examples, but this is the main idea of this. Okay. Time out, yes? I'm not saying that there is no inhibition. Actually, there is inhibition, and for example, Christoph Koch, in a recent paper, even established the exact part of the corpus callosum where these strong right to left inhibitory influences go through. I'm not saying there should be inhibition. Actually, we develop dominance, for example, for language in the left by way of inhibition. it is important to exert inhibition from one side to another. And actually, we are utilizing these inhibitory effects also in rehabilitation. For example, the Sprague effect. If we want to facilitate bottom-up allocation of attention to the left, we can cover the right eye and inhibit by this visual stimulation for the left superior colliculus, thus disinhibiting the right superior colliculus. This is actually the Sprague effect, famous Sprague effect from the 60s in science paper. So I'm not saying that there is no inhibition. I'm not saying that the reciprocal inhibition is the wrong idea. I'm just saying that the whole story is more complicated, and you may do harm. You may do harm. Let me show you just one thing, and you will be convinced. You see here, some patients with neglect don't have paralysis. This is a very good situation for us to see how they bisect, for example, lines with the right hand and the left hand. Now, if the idea is at all times to excite the right hemisphere and inhibit the left hemisphere, this is what will bring the best results, okay? As you may think, if you follow the line of theorizing of Marshall Ginsburg or Christoph Koch or Sprague, yes? See what happens in this patient. This is the condition of the patient when he performs a line bisection. You see this is the line length and this is the arrow. Okay, this is the left hand and this is the right hand 4 weeks after the onset of stroke. You can see actually a disadvantage here for the right hand. Right hand is left hemisphere, not the left hemisphere, not the right hemisphere. The left hemisphere is showing the advantage here. And this changes at 10 weeks after the onset of stroke. So actually there is a dynamic here, a longitudinal dynamics that you have to consider. The left hemisphere is not something that you would like to inhibit at all times after the onset of stroke. At some times, this is the only way the patient can allocate attention in space, in the early stage, okay, when the entire right hemisphere is probably, edematous and malfunctioning as a whole, okay? So you need to know when it's the time of transition from left hemisphere advantage to right hemisphere advantage if you want to apply this kind of neuromodulatory stimulation.
I was intrigued by your Stirling experiment. One thing I found strange there that it took time for between the Q onset, the SOA that you had the best result was about 100 milliseconds, if I remember correctly.
Yes.
50 milliseconds. And
100.
the immediate one.
And not?
Not the immediate one, because you would expect anything that you would get better results for the immediate one than for the. So it seems that it's taking time for something to develop. I don't quite understand it. And one thing
I don't recall if we. I think that we did also simultaneously. Yeah. We did simultaneously, and actually George Sperling found the best result with the simultaneous presentation of the cue, but we got it in 100 milliseconds. Why is that? I don't know.
You're doing multiple comparisons. This may just be by luck, but if you're looking at 50 milliseconds,
I don't think.
50, 200.
Yeah, but we see, there was a pair of 2, and then there was a pair of 4, and a matrix of 4,
what is the mechanism that you think about this? That it would take time to develop. This is something that I find intriguing. But I don't have an answer either.
but think, for example, when you see a face. For the primary categorization, it takes, I believe, 170 milliseconds on average. If you believe Shlomo Bentin, at least that's what he says. Anyway, so 100 milliseconds. I don't know what stage of processing we are. So maybe you need some time. You need some time for the stimulus to be established in the iconic store, no?
But that's not the case in the controls, right?
You mean in the original spelling? Or? Yeah, that's true. That's true. But this, I don't know. This was a different paradigm, and
just following up on that question, if you continue to present cues seconds could you sustain it? You wouldn't have any decrement, right? If it was just a matter of
here in this experiment,
arrive.
we didn't do. George Sperling actually manipulated everything in this paradigm, but we just manipulated stimulus onset asynchrony, not even the exposure duration. It was 32 milliseconds for the stimuli and 100 milliseconds for the cue in all the experiments. It was very laborious, I can tell you. It's not very easy to do it with stroke patients, but that's what we did anyway. But maybe if we prolong the cue longer, I don't know what would happen.
I think it's an interesting insight into what the patients may be experiencing. If it's really a matter of having formed some image and then it's fading away unless it's sustained by some kind of cue. And if the cue continued to be present, maybe they would be able to hold on to it longer. But I think it's a really nice paradigm to explore this.
True, but largely forgotten. Although it's a classic, it's largely forgotten. Very few papers on.
Can I just ask a question about the sound? If the sound is moving from space, from the good side to the bad side, does the patient experience it as disappearing when it goes into the occluded part of?
No.
The patient doesn't even notice that it disappears?
No. It will not disappear. Actually, we have done a very nice experiment about this. We presented auditory stimuli from left and right in free field stimulation. And these were consonant vowels like ba, ka, da, la. And we scored the correct identification of the patient. And it was around 70% when the stimuli came from left-sided loudspeaker, 1.5 meters on the left, as opposed to 95 on the right. But see what happened when we placed another loudspeaker in the room, in front of the patient, a bit to the right, but still in front of the patient, but a bit to the right. We then delivered again the stimuli from the left, and what happened is that the identification rate came to 95%, because at this time the patient believed that they are hearing it from the dummy loudspeaker. And then we moved the dummy loudspeaker to the left, 30 degrees on the left, and delivered again the right-sided string, okay? The one that they perceived with 95% accuracy before. What happened is that now the patient who believed that they are listening to the dummy loudspeaker on the left performed at 75% correct response. This was a neuropsychology paper years ago, 15 years ago. So it's tricky what happens in this patient. Actually, what it shows that what determines the neglect in the auditory modality is not the placement of the stimulus in the physical space, but in the representational space, where he believes the stimulus to come from.
Take one last question from Are there consistent biases in the line bisection task, doing it using the right hand and the left hand in controls?
What do you mean controls? Normal controls?
Yeah,
normal controls perform up to 100 milliseconds around the true midline. Probably at least those that are considered normal in my department, I mean myself and the nurses and the doctors, the error is about 1.5 millimeter on average, with the largest lines.
And the right hand, using the right hand or the left hand, the other bias?
It's not. You see, we used to do it in paper, and the line is 1 millimeter wide, and you do it with a pencil, which has its own, So I don't know. It's very close one to each other. But there is an error in line bisection for normals, of course.